Welcome to Black Hat Windows Security Conference 2002, held February 7th through the 9th in New Orleans, Louisiana. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated.
All right, this is the general outline. We're going to do the hardening. We're going to do some recommended deployment models. The connection string conundrum, which this often comes up that people say, what do I do with the connection string? Do I put it in global ASA? And everybody complains about that. That's mostly the place, Microsoft recommends that you place it there. It hasn't been bad except when you've had, you've had source disclosure vulnerabilities, things like that, that have made it so that placing connection strings in files turns out to be, not everybody's too happy about doing it. And the sad fact of it is that even with .NET, it's recommended that you place your connection strings by Microsoft in the web.config file. So we'll look at some of this and what people are doing to try to circumvent some of the connection string problems. Native SQL Server security strengthening. This is, if you're saddled with just having to use SQL Server's security model, some things that you can do to try to improve it. Yes, it doesn't have, strong password enforcement. It doesn't have any kind of a link. It doesn't have any lockouts, all this kind of stuff. We'll look at ways that you can actually go back and try to add some of this to the existing system. Data encryption options. Everybody always asks, hey, I want to store something encrypted in SQL Server. Does it support encryption? Well, no. SQL Server does not really support encryption. But that's really not the best place to be doing that type of thing anyway. So we'll discuss what people really are doing to encrypt data when they use SQL Server. Intellectual property protection, privilege escalation attacks, SSL over TCP/IP, how to. The reason I'm doing this is because everybody always asks. Because it's not something you can just go in there and flip a switch and you've got SSL. It is a little more complicated, and I've got 2 or 3 slides in there where I just quickly show somebody how to set up SSL with SQL Server using readily available tools. You shouldn't have to go out and purchase anything else to do that. And developing secure .NET applications for SQL Server. Unfortunately, a lot of people are under the belief that just because you use .NET, you're not going to have a lot of these problems that we're having now because they've solved all that. It's not true. You can make the same mistakes in .NET that people are making now when it comes to using SQL Server, and we'll look at some of those. And I'm also going to show you the new version of SQL Ping that I did it's about 2 or 3 weeks ago. I had to code it up real quickly for Black Hat. So the first version of it is GUI based, and I may go back and rewrite it at some point. But right now, it does work, and we'll take a look at what it does. Hardening SQL Server. The first thing we need to do is identify application requirements. Client.lib support, or netlib support. We need to understand exactly what the clients need. Microsoft has done a better job, I think, of trying to scale down the prolific netlib support that currently exists. You'll see, by default, TCP/IP sockets is the enabled netlib. That's probably all anybody's ever going to use, but protocol encryption requirements, extended store procedures that are required, Windows or native SQL Server security model, determined privilege level needed. What I'm trying to say here is you can't just do some things and make SQL Server secure. You have to understand the application and know everything about it to make sure that what you're doing is correct and is going to work. And I can tell you things to do that would help make the SQL Server more secure, but if you turn them all off, the application's probably not going to work anymore depending on how it was written. So you have to really go in there and make sure that you understand exactly what the application needs before you start tweaking around with things too much. During installation, you have the option to create an account for SQL Server. Well, actually, you need to do that. But you have the option of assigning the service account for the SQL Server to be that account. It seems like a lot of people just click local system when they're presented with this option because they didn't take the time to go and create some other account. And local system works. So it's a very easy thing to be lulled into. And I implore you to take the time to actually go and create a new account for SQL Server. And it can be a low privilege account. It doesn't even have to be a domain account. It can be a local computer account. Create this account, give it very little rights. A member of the guest local group will work. Choose an NTFS partition. Always set a strong SA account, even if you're going to leave it in Windows authentication mode. If you're going to leave it there, that's fine, but just make sure that the SA password is just something long and difficult. If you never use the SA account, that's fine, but just don't put any, don't leave it blank, because what's going to happen is if some point down the future somebody comes along and changes the mode, even if it's just to test something, that's a window of vulnerability. Even if they change it back at some point in the future, you don't want to leave yourself open to that. So go ahead and set a strong SA password. And scan the temp files. They say that they've had some issues in the past where during setup they were storing some credentials. This is more related to the service packs more than anything else, but I always do a quick scan. The service packs, you definitely want to do this. Just look for your machine. If you know what your SA password is, just do a quick scan for any files that might contain it. All right, if you change context post-install, what I'm saying here is if you've already made the mistake and you've installed SQL Server as local system, you can always go back and fix this. The problem that you're going to have is this low privilege account is probably not going to have access to the right directories. It's probably not going to have the necessary privileges on the registry keys that he needs. So what you need to do is use the Enterprise Manager MFC plugin to actually do that. Don't go in to the Service Control Manager and try to just change the account in there. The thing will blow up on you. Will not be able to start. So you're going to have to make sure that you use the MMC plugin when you change the context post-install. Enable auditing to match your policy, because it's disabled by default. Remove unused netlibs. This is just a good tip. There's no need to have the other netlibs if nobody's ever going to be using them. And there's no telling what kinds of problems that might surface later with those netlibs. For local-only installs, I actually just remove them all. You can still make the connection to the SQL Server using the shared memory netlib, so you don't really need any of the netlibs if you're just going to be using it on your local machine. Use TCP/IP as it is the easiest to configure. Allows for Windows auth and is firewall friendly. This is just a general, there's nothing else that you're really going to need. They've already basically slated the others for obsolescence. The IPX netlib and all that stuff, it has to go away because none of it supports multiple instancing. Disable unused services. The distributed transaction controller. Anybody in here know what the distributed transaction controller does? Exactly. So, you may not need that. You need to look into the application, ask your developers if they're making use of this or anything. You probably do not need that at all. SQL agent, if you're going to do jobs, alerts, create operators, that kind of thing. If you're not doing any of that, turn it off. You can always re-enable it later. Microsoft Search is the full-text search engine. You probably might not need that as well. I mean, it's amazing to me that the things that just get thrown at you, you don't even know what they are. Your machine's probably booting up 5-10 seconds longer because of them. So good policy, get rid of them. Intrusion detection and auditing. Alerts can be used to warn of failed login attempts. Here's just a quickie I did. This is a sample. I'm not going to do a demo of it right now, but all we're doing here is just go ahead and we create an alert that tells us when somebody does attempt to log in as the SA account. Why you would want to do this in real life, I don't know. The idea is more of a demonstration just to tell you that you may not have real good auditing as it is now, but there are things that you can do that you can kind of tweak in and try to enhance some of the functionality that's there. But this would give you the chance to be somewhat proactive about somebody trying to log in as SA. Check the C2 guidelines. This stuff is out here. You can go right to the site. They'll tell you exactly, step by step, what store procedures you have to remove and everything to be compliant with the C2 guidelines. It's a good document to go ahead and look at. It's only been evaluated on NT 4.0, unfortunately, but the SQL Server stuff there is real good, so you should definitely take a look at that. Drop unneeded extended store procedures. This is kind of one that will keep you a little bit below the radar screen. It's one of those low-hanging fruit problems. Really, dropping an extended store procedure doesn't get rid of it. I mean, all that happens is the reference, the matching of that procedure name to a DLL has been removed. But the DLL still exists on the machine. So someone with appropriate level of permissions can still go and add the thing back. But what it would do is if somebody had an automated script that was making use of XP command shell, or somebody that was kind of a kiddie level that understood enough just to be able to execute commands, but really didn't understand how to do things inside SQL Server, would probably be stopped right there. So if you're not averse to just raising the bar a little bit, it's probably a good thing to do. All right, minimize access to all servers. This goes without saying. Whatever it is that you are going to, so if it's going to be in a DMZ environment, make sure that only port 80 comes in. If the SQL server is going to be behind another firewall or something like that, make sure that only the TCP port that it's listening on is open. Use minimal access rights for all services. No running as SA. You should always create some type of low-level account for any type of access and then only give that account the privileges necessary to do the job. Encrypt traffic over unsecured networks and keep it simple. A lot of people can get really complex with this stuff and they think, well, I'll take the connection and I'll pipe it through this thing and then I'll stick it over here and you get too far with this and what happens is it becomes so difficult to mess with that it's a headache for you to manage. Just do the right things and try to keep it as simple and as secure as possible. All right. This is a sample deployment. This is a client-server model. I'm not sure how many people are still writing client-server applications. But if you do, this is a sample way for you to set that up. I don't use Visio, so you're going to have to bear with me a little bit on my graphics. But basically what we want to do is have a SQL server, use the encrypted netlib or SSL. This is assuming that we're on an unsecured network, if there is such a thing as a secured network. Windows authentication only, and forced protocol encryption. And then every client obviously would have to establish some type of SSL connection to the server. So at least you would have the capability to make sure that nobody sniffing on the wire is going to see any of your SQL Server data. And a secure deployment model for an intranet or intranet application, this is a little more complex. What we want to do is we have to make sure that we separate the concept of IIS's anonymous security with SQL Server's security. A lot of times when you tell somebody integrated authentication, they confuse what we're doing between the web server and the SQL server and what we're doing between the client and the web server. The client is anonymous, right? I mean, in most applications, the client's just in there browsing around unless you're using some type of basic or NTLM authentication. What's happening is he's basically being mapped to another user, the iUser account, by default. Then he goes through the firewall. He gets to the web server. He's in Windows authentication mode. This is behind the scenes. He's in Windows auth mode. And if we're talking about here is SQL Server's connection, we're not talking about the anonymous user's connection in IIS anymore. We're talking about the SQL Server connection is going to be the iUser machine. Now, that may sound a little funny. If I'm impersonating and the person just logged in, they've been given an account, the iUser account, as the anonymous account, and then they want to make a connection to my SQL Server, that's the authentication. That's what you're going to see on the SQL Server when you try to do something. That's the account that SQL Server is going to see. Now, if you switched it back to mixed mode and then you put in SA whatever, then that's what he's going to see. But it's just going to pick up whatever context that person is running as in your application. In the case of anonymous access, it'll be iUser. It's kind of annoying looking, but you may have to create, if you use that exact name, you'd have to create an account on the SQL Server called iUser_machine, whatever that machine's name is. Some common misunderstandings. The iUser machine cannot be using allow IIS to control password. That's a problem for most people. That's usually where the thing stops, because they try to do this. They set up a SQL server on another machine, and they say, okay, now I'm going to have a trusted connection, and the thing blows up in their face. The reason it blows up is because when you use this allow IIS to control password, there's actually something called the IIS sub DLL. It's a sub-authenticator that changes the way that he does user context switching. Instead of calling the local user API, he creates a network connection, and therefore he's not going to be able to do a hop onto your SQL server. So you're going to have to turn that off. When you turn it off, you'll be prompted for the password, and that's what you'll be plugging in. And the password will be stored in the IIS metabase. Again, the password will be stored in your IIS metabase. I'm just making sure that's clear. You can also use a domain account if you have a DMZ domain. This is probably a better option. Yes. Making it clear. If you don't like having the iUser machine, what's kind of annoying to a lot of people is, if you have a web farm, then that means you got 5 machines you got to go and do this for, and then set their password equal to the same password that you set up on the SQL Server machine for the iUser account. You can also just use a domain. If you have a domain in your DMZ, then that kind of solves that problem, and all these machines are members of it. Then you can just use a low-level, hopefully, low-privilege domain account that can then make these hops, and then you won't have to deal with password synchronization. All right, where do I put the connection string? This is one that comes up a lot. I'm kind of mixed on it. I have mixed feelings. I still debate about it myself because my feeling is I shouldn't have to worry about where I put the connection string. I should be able to put that connection string and know in my heart that the handlers are not going to allow the viewing of my connection string by some source disclosure vulnerability. When you put your connection string in global ASA, do you feel safe? Is that a safe place to put it? That's where you're supposed to put it. People, obviously, they lull themselves into a sense of, well, if I just put it somewhere else, I'll put it in the registry, or, I'll put it, in some encrypted file somewhere. And they'll really go crazy with all this stuff. And the bottom line is, no matter what you do, if the application can get at the string, and with enough knowledge about what the application is doing, then they can get access to your connection string. So, I'm not a fan. I don't like the encrypt it and store it somewhere else kind of methodology. Yeah. My view of it is do everything that you can to get the secrets out. Get the secret out of the connection string. Therefore, I don't care. I'll put a global say, oh, you got a source code, disclosure vulnerability. You can see my connection string. Oh, great. It says trusted connection equals yes. Good. All right. Obviously, Microsoft recommends the Windows authentication mode. The existing applications are still not doing that. And we'll talk about some more of this later, but apparently what's happening now is we are starting to see some of this in Microsoft applications. It just so happens that I installed the latest SDK for the .NET framework, and there's actually trusted connections in there. Also, the iBuySpy reference site for ASP.NET is starting to use integrated authentication or Windows authentication mode now. So it's very good that they're doing that. So we're actually going to start to see some of this, hopefully. All right. Absolutely. If you can do Windows Auth, do it. If you have any problems with it, it's probably related to using the sub-authenticator or not getting the passwords in sync. Or you didn't create an account on the SQL server that matched the impersonating account on the IIS servers. All right. Going back, strengthening the native SQL Server security model. Some people just, whatever the reason, we got to support mixed mode. Maybe the applications have to do it. Maybe we don't want to set up a complex model, or maybe I'm an ISV and I don't want to force my customer to have to go and do all of this Windows authentication, magic to make all of my applications work. If I just use a connection string, everything will work. Well, if you've made that decision, there are some things that you can do to try to strengthen it. I'll come back to this. I have some more thoughts on that, but I'm trying not to go off on too many tangents here, so we'll come back. Physical network isolation is imperative. Install a certificate to protect passwords in transit. At the very least, set alerts for failed logins and send netset results to the administrator, and modify the SP password system sort procedure to perform complexity checks. What I'm saying here is just do everything that you can to try to add something to the existing system, if you have to support it, because there's really not a lot there. I mean, if you install SQL Server, logging is disabled. The logs are generally just going to say stuff. If somebody tries to log in, login failed for user SA. You got no information about what is really going on. So this is just stuff we can do to beef up. All right. In this case, let's just say we're going to try to beef up some of what's going on with the SP password store procedure. Enterprise Manager actually uses this store procedure to do its changes. So whatever changes you make here are fairly global. So if you want to make sure that a password meets some type of complexity requirement, there's no reason you can't go in to the master SP password and modify this thing to do something. In this case, let's just say we want to make sure that anybody who puts in a password has to be a minimum of six characters. So we go in, we go ahead and add a message. The reason I'm doing this is because if the user doesn't enter a password that has enough characters, we want to let them know. So we'll go ahead and create a system message. 5001 is where the user-defined messages begin. And just say password does not equal complexity requirements. Then we have to go into the SP password store procedure, and then we'll add this little piece of code right here. And all we're going to do is just, if the length of the password, the new password this person has provided, is less than 6, then raise an error. And the message being the 5001, the exact one that we created, return false, or will return an error in this case. We don't want to return 0. Anybody have any questions about that? I know I went over that kind of fast, but it's just a sample. This is probably not the strongest way to check somebody's password. I mean, you're going to probably want things like complexity and all kinds of stuff, but it's easy to add at this point, you can see. You have complete access to the code that's in SP password, so if you want to beef it up, by all means. Data encryption. Basically, there's two, in the COM world, you have a couple of ways to do this. Just get somebody else's COM components or write your own components using the crypto API. In .NET, the framework actually has classes to support encryption. The triple DES and trying to think if the RC algorithms are in there, but I know triple DES and DES are in there. Extended store procedures is another option. All this does is it just allows you to have a plug-in, just a DLL that you can add to your SQL server to do the encryption. My only beef with that is I like the way that web servers scale better than the way that SQL Server scales. So if you're going to put all of the encryption load on the SQL Server, it might not be the best idea for you, but it is an option. And file level, if you're interested in just protecting the actual MDFs themselves, the actual SQL Server files and not row data, there are some companies that offer some protection for files, and of course you can always use EFS. All right, the real issue is where to put the key. And this one is another one of those head shakers. If the application can read the encrypted data, then the key's got to exist somewhere. We're talking about symmetric encryption in this case. The web server is probably not a best place to store it. It's kind of volatile. It's hard to manage keys in a farm. But it's possible. Storing the key in SQL Server is like taping the key to the lock. Exactly right. I mean, if someone's already got access to your encrypted data and the key is in that same place, it's going to be trouble. There is a somewhat of a solution that has been proposed by a couple of different. I've read this and tried this in a few areas, and it does work. And that's just go ahead and use asymmetric encryption. And what we're going to do then is basically have the application do all of the encryption with a public key, and the private key be stored off-site. If your application actually requires this type of protection, that's an option for you. But with the symmetric option, that key is going to exist somewhere on that machine. So just raise the bar. Don't store the key in the page. Don't store the key someplace where it's easily accessible. And if possible, maybe obviously don't want to store it in plain text. So here's the sample of what that data encryption option might look like with asymmetric encryption. You have your credit card data. You generate a random session key. You encrypt the credit card data with the session key. You encrypt the session key with the public key. You store the encrypted session key and you store the encrypted credit card. And off-site somewhere is the private key. It's not going to be a great fit for all applications. Some people need access to the information on that same machine. That's going to be a problem because then you'll be storing the private key somewhere in that farm, somewhere on that SQL server, and then you got another problem. Hopefully, the private key will probably exist only in another application that accesses that SQL server from a secure backend. All right, intellectual property protection. This one comes up a lot. People are always asking, well, I wrote this great application, but it's got all these, it's got all my stored procedures in it, but what's to stop somebody from, just stealing my stored procedures? So Microsoft provided a with encryption option. Unfortunately, it's been broken. It's poor implementation. It's trivial to break. There's already scripts out there that will show you how to take anybody's encrypted store procedures and turn them back into plain text. So on both SQL 7 and on 2000. So I would not rely on that. If you have some piece of code that just can't be stolen, it's just so private and so, such a source of revenue for you that if somebody was to take it, you would be in big trouble, then I wouldn't put it in the SQL Server. To be honest, it probably wasn't very good code if it was written in TSQL anyway. So you should really be focused on where your database structures have been altered. Use a query to indicate changes to procedures. This would give you the capability basically to, if you go into a customer site, a lot of times they'll say, I'm having this problem, having that problem. You need a quick, easy way to go ahead and compare these procedures. And this is just a sample that I did here that just shows you how you could make sure that the content of the stored procedures has not changed. So you would have one pristine machine that makes a call out to the questionable database and does a comparison of all of the objects to make sure that those objects in that target database have not been changed from the source. Whatever the one you have on your laptop, for example, might be the pristine one, and you walk into the customers and run this and make sure that whatever the customer has matches whatever your pristine database was. DBOs, or DDL admins, gone bad. What I'm talking about here is a lot of times people will hand out these DDL privileges fairly frivolously. They'll turn around and say, well, so-and-so needs to create data. So you got 500 developers. They're all DBOs or DDL admins, and they're creating stuff left and right. You should treat the DBO as a very, very high privileged account, because it is. It's not something to be how should I say, frivolous about giving out. The reason, DBOs can create stored procedures that don't check the rights of the stored procedure against what that user's capabilities are. For example, a DBO can write a stored procedure that runs XP command shell. If a DBO attempts to run XP command shell, it fails. But he can write stored procedures that do it. He just can't run them. That allows them to do all kinds of crazy things. And one of them is this. I just wanted to show this real quick. Our DBO creates a Trojan procedure, a DBO XP command shell. The reason that this works, and it doesn't work with regular procedures, if you notice there's an XP prefix on extended stored procedures, there's an SP prefix on system stored procedures. So what ends up happening is you can't really create an SP stored procedure in your database that matches one in the system, because it'll go looking in the master database anyway when he runs it. So it's not going to work to try to replace, say, SP password with something else. But what you can do is replace the extended stored procedures, because I'm not saying replace really, but what I'm saying is you can create new ones that look like the ones that are in the master database. And if the system administrator is not real good about making sure that when he runs those stored procedures that he does it in the master database, eventually he'll slip up and run this thing. So what I want to do real quick, all right, let's say our DDL admin is going to come in today and do some work. And for the sake of argument, it was horrible, and we couldn't use Windows authentication for this. So. Sorry, I screwed the pooch on that one. Yes, the password is test. If I can type it correctly. I'm not plugged into the network, so you can stop attempts. All right, so the DDL admin is in here. He's cranking away. And he writes this little procedure. He checks his role membership. All right? There's only two system administrators right now. One of them is the built-in administrators group. The other is the SA account. So the system administrator shows up after he's created this procedure. So let's go to our target database. Let's just say, for the sake of argument, that pubs is really our database that our application is on. So the system administrator comes in. There's actually now a stored procedure in the pubs database called XP command shell. So the SA shows up. He goes in. He's doing something in pubs, performance tuning, query optimization, something. And he decides he needs to run a shell real quick and get a directory. There's two things that I wanted to do here. One is go ahead and add myself to the system administrator's role. And on top of that, I'm going to go ahead and execute whatever the system administrator was attempting to do. The reason I want to do this is because I don't want him to know that this has happened. I don't want some kind of message to pop up and say, hey, this guy's been added to the group or whatever. And it'll be an immediate sign to him that something has happened. So by executing his command, let me make sure I get the right one. There he is. He's in here and he says, okay, I'm going to go run a shell. Forgets to go back to the master database. He's still in pubs. I want to get a directory. And he gets a directory. No big deal. Goes back to work. Didn't think twice about it. Now we're a system admin. That's it. Negative. No. And what's funny is, by default, when you're using this in grid, you see I'm using grid mode here for the output. I can switch this back to text. And you will see. So if this guy's coming along and he's actually in text mode, not the default, you will get a message. It's right there. Now, how many people will actually take note of that, I'm not sure. But if you thought about it hard enough, you could probably find a way to get rid of that as well. Any questions about that? All right. Maybe there's some other store procedures we want to try, XP who, whatever. You can imagine a whole set of these things as kind of a trap that you lay. And of course, you probably put some type of code in there to alert you of the fact that you had just become a system administrator. But the main purpose of this was to let you know that DDL admins have quite a bit of capability because of the delayed compilation of the store procedures. Because he can create store procedures to do things that he can't really do, there is the potential there for misuse. All right. SSL over TCP/IP. This is, I'm doing this basically because I think Microsoft really needs a real clear document of how to do this, because they basically just say, get a certificate and then you can do this. But a lot of times people don't understand exactly what this means. When SQL Server starts up and it's trying to use SSL, it needs a certificate to do this. And it'll either find one in your machine's secure store or certificate store, or it'll find it in the certificate store of the service account under which SQL Server is running. So what I'm basically going to just do real quick is just go through the steps of how to get a Microsoft certificate services set up, and go ahead and request a certificate for our SQL Server. I'm going to go through this kind of fast. This is a very technical crowd here, I assume. How many people have installed certificate services and issued themselves a certificate? 2, 3? All right, so we'll just step through this real quick. You log in to the server somewhere, my server, you log on to the box as administrator, the SQL box as administrator. You navigate to my server, cert SRV, request a certificate, advanced request. What's really important here, because I'm trying to make this a step-by-step process, is that you understand that when you get a certificate, you need to make sure that the account that you're getting the certificate for is really the account that is going to be running SQL Server. There's two ways to do this. The one I'm actually listing here is we're going to log in as an administrator for the purposes of putting it in the machine store, right? Because I told you there's two places the certificate can live. It can live in the machine store or in the store for the account under which SQL Server is running. So if you're going to do it the second way, you want to store it in that store and not the machine store, you need to log in as the user under which the SQL Server account is actually going to be running in order to do this. Log in, request the certificate, say you want an advanced request, submit the certificate request to the CA using the form, fill in all the fields, make sure you get the DNS name right, and use the local machine store and submit. Install the certificate, then load the server, network utility, and say force protocol encryption, and now you have SSL. It's really that simple. In this case, we're actually going to use the machine's store, and it's really the simplest way to do it. Because I just want to make sure that you understood that this is not the only way to do it. You could also log in and not get it for the local machine store, and it will actually, the certificate would go into the certificate store of the user account that you were using for SQL Server. So you have either one of those two options. This is just a sample of what the form looks like. There's the first statement is exactly what I just said. If the statement does not trust the CA, then the client will not be able to connect. And this is what comes up all the time. If somebody's saying, hey, I did all of this and it doesn't work. So I just want to make sure that there was a step-by-step process that's repeatable that you can do yourself to just get the thing set up so you can start playing with it. At some point, you may decide that that's too much of a pain because when you use Microsoft Certificate Services, you have to deploy that certificate for people to trust it, right? If I have a cert server and I go ahead and issue a certificate, well, if the client doesn't trust that CA, then the SSL isn't going to work. So you're going to have to do a little bit of client-side deployment to make that work. And that's why if you just go get a certificate from VeriSign or Thought or one of those guys, you can avoid a lot of this because those certificates are already in your trusted root store. All right, managed code. In .NET, the framework portion of .NET, there's this concept of managed code. And basically what's going to happen is every time you run an application, the code really is just running in a virtual machine, a little box. So what's going to happen eventually with SQL Server, supposedly, is that it's going to be running a lot of these store procedures and everything that goes on in the back end of SQL Server in the same box, what's called the CLR, Common Language Runtime. This is going to open up a lot of things. One, you'll be able to write store procedures in languages besides TSQL. You should be able to use any one of the .NET languages. Another thing is in the ASP validation controls, there's the concept of all these things that we were talking about in Tim's presentation, validating input, making sure that that it looks good, it's got to be properly sanitized, make sure it doesn't contain single quotes or whatever. The ASP.NET controls do a lot of that for you. They can check for size. They can check for did somebody put a single quote in, or is it a number? Hopefully people will make use of these things. Apparently what they're trying to do is make it so simple to do sanitizing that people would be crazy not to use it. Data sets and data reader classes were probably going to be the most likely ways you're going to get data out of the SQL Server. But keep in mind, it doesn't stop you from being able to do the string building technique and still having SQL injection problems. That stuff's not going away. You still have to make sure that you make the request the proper way. The crypto API support in the framework, that's going to be interesting because that would mean that you would be able to do encryption right there on the SQL Server inside your store procedure using the framework classes. So if that was an option for you or something that you really like to do, it'll be much more easy to do it on that side. There's more business logic happening on SQL Server. That should be interesting. I'm not sure how many people are actually going to do that. I'm not even sure if that's the best model to be putting a lot of business logic there. But it certainly makes your database development much more robust. And of course, there's Longhorn that's out there, supposedly rumored to include some type of relational data store. a SQL Server on every box. We'll see. All right, here's an example of the wrong way to perform data access in .NET. So we've written an application here. It's a C# snippet. And we're going to go ahead and create our connection using some type of connection string. I'm not going to say where it came from. We create a command object, and we're doing the same exact thing, right? And just put some select, star from authors where author name equals to something in a text box. This is a poor way to do it. It's the same old way, the same old problem as you had in ASP. Do not do this. But there's nothing intrinsically in .NET that's going to prevent the same type of problems that we have now. The only thing that's going to do it is good coding practices. All right, the right way to perform data access in .NET. Go ahead and create a connection, create your command. In this case, just the store procedure name. We're going to tell it that it's a store procedure. Go ahead and create a parameter, strongly typed. Assign the value, add the parameter, open, execute reader. This is a better way. Code access security. Now, managed code can be assigned to various code groups and permission sets. This is very interesting and something we should definitely be taking a look at. It's the concept of a call stack, where a piece of code can take another piece of code, call out to it, and that called out piece of code be subject to the same set of restrictions that the piece of code that called it was. So if I don't have access to run SQL client and I invoke another piece of code that tries to do something with SQL client, then that should fail. It should throw a security exception. Permissions can be asserted by code or denied by code to ensure minimum privilege. And I'll show you an example of that in a second with using attributes. In .NET 1.0's two goodies for database developers are the SQL client and the OADB permissions, and that'll be in the sample. And if you look, there's a little piece of code with the brackets. It's right on top. This is actually something that you can place on top of your methods to say, for this particular method, I want this particular permission to be given or denied. Keep in mind that these restrictions will only apply to managed code, which you have specially marked via permission attributes or defined by the runtime security policy. It's something to keep in mind. This isn't, magic security elixir. It's only the stuff that runs in the managed code environment is going to be subject to this. So if someone uploads some Trojan file to your machine, managed code's not going to protect you from that. But we're talking about the exploitation of your application or the introduction of new code into an existing application. So here's a sample, code access security. All we do here is we just open up a connection to the SQL server. It should go through, if I have permissions, and just return the calling method has been granted sufficient permission to access the database using a blank password. In this case, they've actually created a permission that's specific to allowing blank passwords. I'm not sure how useful that would be. You could do that yourself, but it is interesting that they included it. So you can basically tell that method, hey, if somebody tries to make a SQL connection using a blank password, I want to throw a security exception. So depending on whether or not, I've put a blank password, we're going to see what he throws. All right, the same piece of code you're looking at right there, is SQL client test. That's what's on here. We'll just pull it up real quick so you can see it. All right, in this case, I've commented out that line because the first thing I want to show you is that it's actually working. So I'll go ahead and run SQL client test. Blazingly fast machine I have here. All right, the calling method has been granted the sufficient permission to access the database using a blank password because I commented the attribute out. I was wondering where you were going to come for that. So, go ahead and put the attribute back in. recompile it. And re-execute it. And the calling method has not been granted, so he threw a security exception. Not the sexiest demo in the world, but hey, it worked. I mean, it actually made a decision about whether or not to throw an exception based on something that could be changed at runtime. It's pretty interesting. So there's all kinds of uses for that. You can create your own. Permissions as well, so you don't have to live within this world of just using the ones that they provided. But it is pretty slick. There is this other set of SQL client permissions. You can also just deny access to the SQL client as well. So you may just want an application to not even be able to access the SQL client namespace. And if that's the case, you can just change that permission as well. All right, new SQL threats. I don't know if I would call this a SQL threat. This is just a threat. But I'm seeing this a lot. You're probably going to hear from everybody. If you use wireless networks, you're going to be insecure. Don't use WEP. WEP doesn't work. Whatever people have talked about, and I've been hearing the same thing. Nobody's listening, because everywhere you go, you're going to find these things. And what I'm finding a lot of is people will put in good NT security policy, and then bunge it up by having all this bad SQL Server configuration. SQL Server is neglected on developer workstations, mainly because I'm not even sure developers really care about how up-to-date their machines are. SQL Server always seems to be the one that gets kicked to the curb. It's not in Windows Update. It's never listed as a critical update. The other problem that you're going to run into is SQL Server service packs are instance-specific. So if a developer goes out and installs something that puts an instance of SQL Server on his machine, probably not even aware that it's there. You've probably installed it for some demo purpose. The thing works, and never really looked to see what was created. So it's just an area of abuse. And what ends up happening a lot of times is you'll do a quick scan, and you'll see 5, 6, 7 SQL servers all sitting there, all multiple instances, all of them probably in mixed mode, SA, no password. It's rampant. If you just wanted to drive around and just enable WEP, or not enable WEP, but enable some type of sniffing so you can get the SSIDs off, get on their network, and just do a quick scan and see how many SQL servers are out there and how many of them are misconfigured. It's frightening. The SDKs, this is a particularly bad one with me, is that the .NET SDKs install MSD and usually lay down SQL Server in a non-default instance with local system context, a blank SA password, in mixed security mode, with logging disabled, and the user's really not aware that any of this ever occurred. If you want to find out, if you just do a quick sweep of the number of people that actually have installed the .NET SDK, and it actually creates an instance called /net SDK, and ask how many developers actually understand that it's on their machines. I'll bet you none of them know. It's a totally different installation of SQL Server that now exists on their machine. They have no idea it's there, so they're never going to apply a service pack to it. The port assignments are fairly random, so if you just do like a quick TCP sweep for 1433, you can't rely on that anymore, because when you get a multiple instance, he's going to see that 1433 is already used. He's going to go get another port. What it is could be anything. So it's not good enough anymore just to do a sweep for TCP 1433 to find SQL servers. Those days are over. I want to reinstate this one because that's a very important one. If you are good about applying service packs, make sure that you understand that SQL Server service packs aren't like other ones. When you install a SQL Server service pack, it is instance specific, and it will ask you what instance you want to install it on. So if you've got 5 instances of SQL Server, you're going to have to install the service pack 5 times. What I did here was I went ahead and wrote another tool called SQL Ping and SQL Ping 2.0, and what it does is it takes what SQL Ping did, which is issue the discovery packet for SQL Server, and I threw a GUI on it because felt like doing it, and I've already got barked at by Eric, so I got to go back and write it in C++ so he can script it. But what it does is it allows you to not only scan for those multiple instance machines, but to go ahead and to do some type of brute force attack against them. And you can do it for IP ranges. So it's not just well, I did a SQL ping and I got back a bunch of machines, and then you got to go visit each machine individually and audit them. It will allow you to just put in your network space and just go through and wham, wham, wham. It'll go to every machine. It'll send one discovery packet to that machine. It will come back and tell them every single instance of SQL Server that's installed, and then one by one through each instance, he will go through and do some type of dictionary attack against every single one and try to dig out some passwords. There's also just a discovery page where you can use the same old functionality from SQL ping and just issue pings and see what gets returned. If you get back version information, a lot of times you're not exactly sure, is version 8.0.194 the original release, or is that Service Pack 1 or Service Pack 2? And there's somebody who's got a site out there, he's actually keeping track of them, make use of it. I don't, frankly, I don't have the time. But if you want to go there, he's got a version map of exactly which one's mapped to which version. So you'll know which vulnerabilities exist on that particular instance. And I'm only aware of one commercially available scanner that does any of this, and that's it. It's called App Detective. These guys, AppSec Inc., developed it, and it's still in beta, but you can download a copy and play with it. All right. Just want to show it real quick. Yeah. Where did I stay? All right. So I'm not connected to the network, so I'm just going to scan myself. And we wouldn't want to scan our fellow Black Hat attendees either, I'm sure. But you can issue the ping. He goes out, he sees himself. You click on that. That'll just set your IP address in here. You can just put a range here if you want to hit your whole network space. You can go in here and click, find your own user list. You can create your own. There's nothing special about it. It's not in any special format. The user list is just a flat file with one after the other usernames that I want to try, and the password is exactly the same, just a carriage return between each one. And what it'll do, scans the machine and doesn't find any accounts to exploit on this machine. So you're welcome to use your own user list. You can see I have 2 users in my user list and 7 passwords. That's the default. So if you really want something more robust, you can go get your own. But what it'll do is, as he's scanning, they'll show up here in the servers found, and you'll have the option when you're done with the scan to save it out as a file or whatever. Any questions about what that does? All right, these are some reference links that I have. These are some common sites that I go to for security information. I recommend you do the same. Some good stuff out there. And some recommended reading. Actually, I just finished this last book down here. This is quite nice as well, with some good tips on securing symmetric keys and stuff like that as well. Anybody has any problems with that? And that's it. Thank you very much. Is there any questions? No questions? Okay. Thank you.